at the National Weather Service Forecast Office in Romeoville, also known as Chicago. Brett's a Oklahoma grad with a BS in meteorology. He served as a meteorologist at the weather forecast offices in Marquette and Grand Rapids, so he's seen a little bit of winter weather as well as the other severe weather in high winds, marine warnings, and that type of stuff. Brett enjoys hiking, cycling, cooking, and searching for fossils in the Amazon Creek fossil beds. So with that, I will turn it over to you, Brett.
Hey, thanks, Craig, and good morning, everybody. It's a wintry morning here in Chicago, our second or maybe even the third day in a row with snow after a beautiful fall. Winter is certainly here and certainly here across a good chunk of central region. So this is a talk. It was adapted from a talk I gave during the National Weather Association conference earlier this year. And today it is aptly named, a 20% chance of heavy snow, would you leave for work early? So what I want to do here is right off the bat, just actually start with a poll. And I want to ask everybody here, just take a moment and ask yourself, how spicy do these peppers look to you? Do these look like they have no heat? Do they look like they're mild, medium, hot, or extreme? And just take a moment and think about that. And Greg, if you wouldn't mind starting a poll here, let's see what kind of results we get across the region. Take about 10 more seconds.
It's like 50% have voted so far.
Excellent. All right, let's go ahead and wrap up the poll here.
All right, 57 have voted. Last chance. Let's get them in. All right, I'm going to go ahead and close the poll. And
go ahead and see the results.
Oh, share. There you go.
Oh, look at that. A nice even distribution with medium, about half of all the respondents, and hot and mild on both sides. Nobody thought they had no heat. Nobody thought they were extreme. And this is great. It shows that across anyone who answered, we have a different variety of answers, probably based on our own experiences and our own tolerances for heat. So why don't we go ahead and close the poll. I'll go back to the presentation here. Well, did you know there's such thing as a Scoville scale? We can use this to measure the heat or the spiciness of a pepper. It goes from 0 to 15 or 16 million, and I have just a few reference peppers on there. Each pepper may be a little bit different than what I have listed, but these should be generally the ranges. And the next question I'm going to pose to everybody, and this is more of a rhetorical question, is where should we put these categories? Where should we put no heat, mild, medium, hot, and extreme? You may notice that the scale I have up there, it is actually more logarithmic. It's not linear. So maybe it makes more sense to have all the categories skewed to the left. Maybe your personal scale is more skewed toward the right, where you don't really taste any heat until you eat a jalapeno or serrano pepper. And by the way, that picture was of jalapeno peppers. Even though a phenomenon may have a well-established definition, our own experiences or thresholds mold our estimations of intensity. So like peppers may have their own specific spice level defined by the Scoville scale, but our own perceptions actually mold how hot we think a particular pepper is. So why don't we look at a jalapeno pepper? That's what the picture was. And why don't we look at this a little bit more closely? And let's say we're forecasting the spiciness of a pepper. So we just picked a pepper outside our garden, or maybe we picked it up at the grocery store. And let's say based on our own knowledge and our own experience, personal experience with, let's say, growing peppers, let's say you went to school with a degree in pepper spiciness, and our forecast is it's going to be 12,500 SHU. And let's say our forecast is prepare for a spicy pepper. Well, person A may say that's not spicy at all. While person B may say, oh my God, call an ambulance. And by the way, that's me. I can't tolerate spice at all. I used to when I was a kid. I had a particularly bad experience with a hot pepper at a restaurant, and ever since then, I just can't tolerate it at all. Well, okay, that's not very helpful. Let's say we can forecast the IQR, the percentages, 25 and 75th percentile forecast spiciness of this pepper. Well, that still doesn't help us out because there's other forecast elements and other factors that may impact the spice level. For example, how big is this jalapeno? Is it really small, only an inch long, or is it like the world's biggest jalapeno? How long will it be in contact with my mouth? Is it just one little lick of the pepper, or am I going to have the pepper in my mouth for 20 minutes? Am I eating this pepper right after eating a hotter pepper? So relatively speaking, it won't feel as spicy. Do I have a glass of milk or lemonade nearby that's going to cut that spiciness down? If we focus on the number or even probabilistic information on the forecast of the spiciness of a jalapeno, we're missing out on all of this information. And at the end of the day, all the information on the right-hand side is going to dictate how uncomfortable I am after I eat this pepper. Now, why don't we turn this a little bit more towards weather? Why don't we take a quick look at Hurricane Ian, arguably one of the most impactful hurricanes to strike Florida in recent memory. And the same thing plays a role here. I was actually watching a lot of news sites at the time, and the Tampa Bay Times had a great article as the storm is nearing the west coast of Florida. And they mentioned that Americans have been conditioned to measure and fear storms by wind. And the confusion is partly our own problem. And it comes from the Saffir-Simpson scale. We focus so much on wind speeds, so much on a number, the maximum sustained winds of 155 or 150 miles an hour. It's just a category 4 or category 5 storm, as if that makes a difference. And that really only takes into account the wind. What about the other impacts of hurricanes, such as flooding, tornadoes, storm surge? That's all just as important. And while we may communicate that in our forecast, that doesn't make the headlines. The headline is whether it's a category 4 or category 5 storm. And the private sector realized this. In 2019, AccuWeather actually introduced the real impact scale for tropical systems. It looks like it's largely driven by flooding, but they take into account other factors, flooding, wind damage, power outages, significant property damage, and coastal inundation. They're taking into effect those measurable or impacts that you can see and feel with your own eyes. And I would argue that's a much better measure of what people are going to feel and frankly, probably will spur more action. Okay, and let's talk about wind speeds in a slightly different format here. Just this morning, very timely, I could not plan this any better. I got a text from a friend here who had sent a picture almost as a joke of, this should be the official Weather Service scale. And I was like, oh my gosh, this is perfect. And you can see my response there. I agree 100%. It'll be better than strictly talking about wind speeds. Because if you look at the scale that was on, it looks like this News 12. I'm actually not familiar with this site. I think they grabbed it on social media. They're looking at these measurable impacts, someone you can see or hear, whether your garbage can is flipped over in the neighbor's yard or you've lost your trash can. And you can see my friend's response there. Franklin said, yeah, I can relate to that far better than arbitrary numbers. And the crux of this is communicating is hard. I can't remember the exact person who said this, but they said the greatest challenge to communication is the illusion that it took place. I think we all understand this. We can put in all this hard work into creating a great forecast, and maybe that forecast verifies perfectly if you look at numeric metrics, probability of detection, false alarm, or a snowfall forecast. But if at the end of the day, the road crews didn't go out and treat the roads, that's a message or that's a signal that our forecast actually didn't reach the stakeholders. And maybe there's a different way to measure that forecast. Maybe that forecast failed because we didn't spur action. So communicating is that last 10 yards. It's the last part of the forecast process that is really hard. And I think a lot of us are uncomfortable with it because, well, we're all scientists. We're all really good at the meteorology. So there's two main obstacles, I believe, to communicating forecasts. The first obstacle is word choice, and there's a couple of subgroups in there: words of estimated probability and words of estimated intensity. And those are really nuanced and really challenging because I think it's so embedded in the way we talk and the way we're taught to talk. And the second obstacle are what I call naked numbers, and those are numeric numbers. We just talked about the spice level or wind speed that sometimes have no context, and there's different thresholds for different users, whether it's a partner, someone in the private sector, or the member of the public. So why don't we talk about these obstacles over the next few minutes here. So let's talk about words of estimated probability. Some people on the call may be familiar with these. I've talked about these before actually in a talk I gave last year. But examples of words of estimated probability are low, medium, high, probable, chance, likely, unlikely, could, might, may, perhaps, uncertain. The list goes on and on. So an example in a forecast is there's a low chance of thunderstorms today. Or, as another example, snow will likely change to rain and freezing rain tonight. Another example, wind gusts greater than 50 miles per hour are possible overnight. And the challenge with words of estimated probability is public or partner perception, it varies and cover a much larger range of probabilities than intended. And this is a great figure. A lot of us have probably seen different variations of this floating around in social media. But this was a survey done by Lenhart et al. In 2020, and they looked at the perception of different words of estimated probability. And it's remarkable to see how no matter the word, expected, possible, may, chance, the percent chance that was attributed to those words spans from 0 to 100%. And you'll notice the little bumps at common percentages like 25% and 50%. and then for expected around 75%. So it follows out those familiar percentages, 25, 50, and 75, but it covers a huge span. And while meteorologists, we may have a good idea, likely means a 55% or greater pop, or a chance is, I don't know, like 20 to 54%, the public may attribute a completely different range as low as 10% or 50% to that. So right there, we have the illusion that communication took place, but in reality, it didn't. So let's talk about some strategies for how we could avoid the problems with words of estimated probability. The first thing I recommend here is to add context by accompanying numerical percentages. And I shouldn't say I recommend, these are actually from social science research here. So for example, there is a low, a 5% chance, literally adding that percentage that we're attributing to that word of estimated probability. There is a low or 5% chance that snow totals will exceed 8 inches. Or we have high confidence, greater than 80%, that wind speeds will exceed 45 miles per hour. By providing that percentage range, we're providing that number to our partners. They can see exactly what our estimated probability is and make an actionable decision. Another recommended strategy is to use comparison statements that indicate relative probabilities. So in the case of severe weather, the probability of a tornado is lower than winds strong enough to down tree limbs. So yeah, there's still a chance of a tornado today, but it's more likely that we're going to see damaging winds. And by the way, notice that we didn't look at a specific wind speed here. We're going to talk about that a little bit later on, but we're talking about winds strong enough to down tree limbs. That's a measurable impact by looking at an impact. We're not talking about 55 or 75 mile-an-hour winds. We're looking at what is the actual impact. Another recommended strategy is to use a numerical ranking system from, let's say, 1 to 5, and we'll talk about that a little bit more later on as well. But scales of 1 to 5 are ubiquitous in our lives. The Saffir-Simpson scale, the EF scale. It's easy to know that 1 is less than 5. It's basic math right there. So it's also recommended to use numerical ranking systems when we're talking about probabilities. And this is my favorite strategy here, is to simply state what we know. And this is especially true in our area forecast discussions or even headlines. And an example here is the storm in question is still 2,000 miles away. There's plenty of time for it to evolve. Our forecast will become refined as the storm nears. I think that's much better than simply saying there's a chance we could have a winter storm next week. This also builds trust with the public and partners by simply stating really the status of the forecast. It gives a sense that, hey, we actually don't know what's going to happen yet, and here's why. And I think that builds that trust that is just so important with our partners. Another example here, and this is classic in the Great Lakes, we never get a clean convective forecast, it seems like up here, but thunderstorms tomorrow afternoon dependent on the coverage of storms tomorrow morning. A higher coverage of storms in the morning would lead to a lower coverage of storms in the afternoon. Again, it's just playing out exactly what we know. It's not making a direct forecast of, yes, we are going to have severe weather tomorrow. It's saying, hey, this depends on this other factor here. And it gives our public and partners something to look at in the morning. If they wake up in the morning and it's storming, okay, maybe we're not going to have bad storms later today. Again, I think that's far better than saying there's a chance of severe weather tomorrow. And this is, I think, a really good strategy. And social science also recommends avoiding these words entirely. And this is really hard. I still struggle with this myself. But they recommend completely avoiding the words possible, chance when used alone, so not using a percentage like a 2% chance, maybe, could, might, may, and perhaps. According to social science, those words are just confusing, and the public and our partners may just not understand them at all. So I know personally I've been trying to avoid those words more going forward here, and it is a challenge, especially at 2:30 a.m. on a midnight shift when my word recall is just not good to begin with. So 5 really good strategies here recommended for words of estimated probability. Now, what about words of estimated intensity? And I think this is going to be a slightly different concept. A lot of us may not be as familiar with these. But what do I mean by words of estimated intensity? Well, let's go back to our pepper example. So words of estimated intensity, I define them as words that may have a well-established definition but differ based on perception, experiences, or individual thresholds. So again, for example, a jalapeno pepper for you may be mild. For me, it's extreme. There's still a well-established scale, the Scoville Scale, but we have different perceptions, and our behavior is going to change based on our own experiences. If a recipe calls for a jalapeno pepper, I'm not putting that in. I'm putting in a green pepper. I don't care if other people want the spice. I'm not going to do it. Whereas you may go for a slightly spicier pepper. So what does this look like in meteorology? I'm going to go through a few examples here. And these are words that we use pretty commonly. And the first example is minor, moderate, and major. And the example I have here is with respect to damage. And I have to give credit to Jim Masco, the WCM out of Grand Rapids, for really enlightening me to this particular example. But what is minor damage? I have 3 pictures here. This is all from the same tornado. This is the Coal City EF3 tornado in 2015, June 22nd. And the question is, what is minor damage? When does minor damage become moderate? Moderate damage become major? We may look at that house in the middle and say, okay, relatively speaking, that looks like minor or moderate damage. But to the homeowners there and the driveway, they have to rebuild their house. That is a major life event for them. That's major damage to them. And in a way, it's almost insulting for us to say, yeah, this is minor damage. It's no big deal. Yeah, on the right-hand side, that certainly looks like major damage. The left-hand side, that looks like a ball field. Okay, maybe that's relatively minor. They can't use that ball field for however long it takes until they rebuild it. That's a pretty major impact. And so when we ascribe these words of estimated intensity, it has different perceptions. When we look at another example here, breezy, gusty, and windy, my question I pose to all of you is, when does breezy become gusty and gusty become windy? My version of windy likely differs from your version of windy. This is one of my favorite examples, light, moderate, and heavy, especially with respect to snow. We're talking about a 20% chance of heavy snow, right? There's 3 different definitions that we can talk about when we're looking at the estimated intensity of snow. Are we talking about the literal weight of the snow? Is this fluffy snow with a ratio of 15:1? Or is this heavy, wet, heart attack concrete snow with a ratio of 5:1? When we say there's heavy snow expected today, what is the public expecting? Are they expecting that concrete snow? We can also look at heavy snow with the context of the rate of accumulation. This is strictly from an NWS definition of heavy snow in the NWS glossary. Snowfall accumulations of 4 inches or more in 12 hours or less, or 6 inches or more in 24 hours or less. We can also look at the ASOS definition of snow intensity, which is based on visibility. Each of these different definitions are probably right in their own lane. But when we say light to moderate snow, it is not clear at all what we're referring to here. And I think more often than not in the Weather Service, we're talking about the snow rate, but I don't think that's the public or public partner perception of snow. So a few strategies to recommend here on how to avoid words of estimated intensity. The very first thing I recommend is to connect the precipitation rate to an appropriate adjective that makes it connectable and relatable. In other words, when I look out the window, can I see the change happening before my eyes? If I were to walk outside, can I literally feel it or hear it? So some examples on the screen here are, it's going to sprinkle on and off all day, so keep a light rain jacket handy. That's in place of light rain. If you have light rain outside or drizzle, that may give the perception that I can just run outside without a jacket. We have a particular phone caller who calls our office. I think all of our offices, we have our fun phone callers. But anytime there's any raindrops falling, he gives us a call and says, hey, I didn't think rain was in the forecast. And he's really upset about it. And maybe that's because we called for a light rain forecast, or a forecast for light rain or a 20% chance of rain. It's far better to say it's going to sprinkle on and off all day, so keep a rain jacket handy. Another example is the snow won't accumulate too much, but still make roads slick. That's a perfect example for what's going on in the Chicago area today. Our visibility right now outside our window is probably 3/4 of a mile, so it looks like it's snowing pretty crazily. The road temperatures are right around freezing or just above, so maybe secondary roads are becoming slick. That's much more relatable and actionable compared to saying light snow. Or another example is it's going to pour snow today. Northwest Indiana, they're going to get just dumped on. There's a pretty mega lake effect snow band in a mesolow heading toward the shore. And if we were to say heavy snow, that doesn't necessarily get the point across that it's going to pour snow and the roads are going to become a mess this afternoon and evening. And a bonus is accumulating snow with that as well. Another strategy is to provide an accompanying rain or snow rate, or another measurable benchmark, something where you can look outside the window and you can literally see the snow going up your ruler. So for example, with rain's going to fall at a rate of 1 inch per hour, which is enough to pond roadways. So we're providing a measurable benchmark, 1 inch per hour. We're also providing an impact there. It's enough to pond on roadways. Or snow is going to fall heavily at times, 1 to 2 inches every hour. That's a strategy that we actually used on a graphic we sent just about a half hour ago. So it's still okay to use the word light and heavy so long as we're providing that measurable benchmark, 1 to 2 inches every hour. Road crews know, okay, this is how much snow I'm expecting on the road every single hour, and that's what I'm going to ascribe to the word heavy. Another recommended strategy is to avoid the word moderate entirely. I frankly can't stand this word moderate because I don't know what it means. Light to moderate, moderate to heavy, I think it's kind of hedging what we actually mean. I think it's far better to avoid that word entirely. Other words of estimated intensity that we use pretty often: minor, moderate, major, very significant, weak, strong. Just like our words of estimated probability, I recommend that we simply state what we expect to occur. So instead of minor, moderate, or major icing, you can state that roads are going to be icy. So minor icing doesn't tell me what the impact is, but if I know roads are going to be icy, I'm going to leave for work early. And when we look at wind speeds or major windstorm, let's connect that to an impact. Downed tree limbs and power outages are expected today. Maybe widespread, prolonged power outages and tree damage are expected. Sure, our specific stakeholders and partners may have specific thresholds for wind speeds. Maybe they know their power equipment is rated for 75 miles an hour, but that's not necessarily true for the consumers. I don't know how well actually all my power lines are underground at my house, but when I lived in Michigan, everything's above ground. I have no idea what those power poles are rated to. The EF scale says, I don't know, 120 miles an hour is what they should withstand, but we all know that power poles vary in health and vary in age. I don't have that information. So if I have a forecast for 75 miles an hour, how can I make a forecast, and how can I know what the impact's going to be? The power company may know that, but I don't as a power user. And instead of, let's say, very windy or extremely windy, simply state what you expect to occur. The winds are strong enough to blow away your trash cans and lawn decorations. Remember that screenshot from the text I showed just a little bit earlier? Or maybe these are tornado or hurricane-like wind speeds. I always laugh every time I send out a severe thunderstorm warning mentioning 60 mile-an-hour wind speeds. It's amazing how when we verify that warning, a train spotter calls in 60 mile-an-hour wind speeds. It's just perfect. It's amazing how well I can forecast that wind speed. I don't think that's what's happening at all. I think that's because we have 60 miles an hour mentioned in our warning. That's what they're seeing, or they think they're seeing outside their own eyes. If I follow up with, okay, is there any tree damage? The answer is usually no, which tells me, okay, maybe the wind speed actually isn't 60 miles an hour. So if we connect it to an impact here, I think that's more likely going to spur an action. Another strategy to use is, again, to provide a measurable benchmark to particular events that individual users can use for their own thresholds. And this is a recommendation I've seen from a variety of sources, but this looks similar to the 2008 ice storm. A lot of us have memories of impactful events. One of the big storms around here is the 2011 Groundhog's Day blizzard. If we were to throw that term around for an upcoming storm, it would be Armageddon. So that's why we don't use or invoke that storm unless we're really confident it's going to happen. Or winds will be strong enough to down tree limbs, providing that measurable benchmark, 45 to 55 miles an hour this afternoon. Boom, we kind of killed two birds with one stone. We give the impact to down tree limbs, but we also provide that wind speed for partners who have those specific thresholds. Or water levels will reach the Chicago Lakeshore Trail tomorrow morning. It's kind of funny when we look at lakeshore flood warnings and lakeshore flood advisories. If you generate the text in the format launcher, it says minor flooding along the lakeshore. I have no idea what minor flooding is, but if we were to call the Office of Emergency Management and Communications in Chicago and tell them, hey, the Chicago Lakeshore is going to flood today, boom, they know what to do. They're going to shut it down. Hey, Lakeshore Drive's going to flood today. Boom, they're going to shut it down. It's much easier to give them a specific impact that we know based off of previous storms for them to take an action. And one other example here for words of estimated intensity, I always give this example here: marginal, slight, enhanced, moderate, and high. We know these mostly in the context of outlooks from SPC and WPC, but did you know that the public perception actually goes slight, marginal, moderate, enhanced, high? That's actually out of order from what we expect. And the recommendation here is to use a numeric scale, similar to the words of estimated probability. So instead of marginal, talk about a level 1 out of 5. Instead of moderate, it's a level 4 out of 5. And a great example here is there's a slight level 2 out of 5 threat today for severe weather. That way we can stay consistent with SPC, or just strictly say there's a level 2 out of 5 threat for severe weather today. And this also gets at a challenge with the outlooks themselves. Just like a lot of things we do in the Weather Service, the outlooks carry more information than a strict probability. And a great example of this is there's no high risk for hail. I don't know if everyone knew that. So while you may have, let's say, a 60% probability that there's going to be damaging hail today, SPC is not going to put out a high risk because there's also a perception of intensity or impact, and that just doesn't reach the bar of a high risk for them. You'll notice high risks are only issued when there's an expectation for violent tornadoes or derecho. That's not necessarily in the directive. The directive is just talking about the probability of a storm report within a certain distance. But again, the outlooks carry a little bit more than just a strict probability. So that's why we're talking about a level 2 out of 5 threat. We're not looking at enhanced, moderate, high, anything like that. So why don't we switch it up here? Let's talk about what I call naked numbers. And these are numbers with no context or different thresholds for different users. And this is going to be a little bit more applicable, I think, to winter weather here. And we're going to do a very quick case study here. Let's take a look at a forecast we put out a couple years ago, tax day in 2020. I've used this example before, so it may be familiar, but why don't we take a look at the graphic that our office put out here. And I should note, I'm not criticizing our office for putting out this graphic. I've made graphics like this myself. I wasn't working for this particular event, but this is what our forecast was. This was our message. And I think it's very obvious that our eyes are drawn to the left-hand side of this graphic. It's a snowfall amount graphic. The public has been trained to look for snowfall amounts, just like the early article from the Tampa Bay Times I showed. The public is trained to look for wind speeds. But the question I pose to all of you is, does this really give the message that we wanted to send? And to answer that question, why don't we watch a quick video of what happened with this forecast?
Multiple cars. It's going to get really bad. North inbound. Oh, snap.
And it did get really bad. Around 5 a.m., a 54-car pileup on the inbound side of the Kennedy at North Avenue. Several vehicles were totaled, all lanes shut down. The snow, mixed with falling temperatures, created a sheet of ice on the roads, and drivers had no idea. Patrick Balson works for a company making ventilators. Considered an essential worker, he was on his way to work in Cicero.
I just came over the bridge there, and there was just a pileup and nothing to do, nothing you could do. It was icy, it was snowing, and there was just a sudden stop. I was trying to be careful, but there's just nothing you could do.
His car totaled. Many drivers reported untreated roads this morning, and not just on the Kennedy. There was a multi-car crash on the inbound Stevenson at Damon earlier, shutting down all lanes there. To crash on the Edens near.
That was our most impactful winter weather event of 2020. Look at the picture here. Notice that only bridges and overpasses iced up. We had less than an inch of accumulation in the Chicago area, and this was the biggest deal the entire year. And the unfortunate reality is, when we put out a forecast with a snowfall map, it doesn't have any information that's in my opinion, actually useful. There's other factors other than snow amount. And in this particular case, this was an unusually late snowfall. It was in mid-April. That's pretty late for Chicago. It was the first measurable snow in over 3 weeks, so the roads were completely clear of any residual salt or treatments. The amounts were less than 1 inch. So you notice that one person that was interviewed said that the road crews didn't treat the roads. And I wonder if it's because they didn't reach a specific threshold. A lot of snowplows use 2 inches at the threshold to go out and plow or treat. In addition, the snow fell right before rush hour. There were falling temperatures, and there may have also been a role of the pandemic. This was in April of 2020. Even though it may feel like eons ago, we have to remember that a lot of the roads were clear. Everyone was staying home. This was the introduction of the age of telework. So at least in the Chicago area, it seemed like everybody was just speeding like crazy on the interstates. I'm not even kidding. It's like people were going 80 to 100 miles an hour for the first few weeks of the pandemic. And all those factors together likely combined into creating this, you want to say, a perfect storm for a really high impact weather event. Yet our message was focusing on less than an inch of snow. So what are the missing informations here? When we're talking about, like I said, naked numbers, we're missing the water content of the snowfall rate, the timing of the snowfall, the duration of the snowfall, the temperature, the wind speed and direction. When we put out a graphic with a snowfall map, all the attention goes on that snowfall map. Even if we may provide this information, let's say on the left-hand or right-hand side of a graphic or a DSS packet, that's still not driving the message. What's driving the message are these naked numbers. Well, what about ProbSnow? Is this the answer where we could look at the probability of reaching a specific threshold? Unfortunately, the reality is probabilistic information still misses the connection to the impacts. It's not obvious. And I would argue probabilistic snow is still a deterministic forecast behind the scenes. The graphic here is the percent chance of reaching 8 inches of snow. 8 inches is still deterministic. We're looking at a probability of reaching a specific threshold. Yeah, sure, maybe some high-end partners can use that information to make decisions, but I don't think the public knows how to use that information. So the question is, how can we use ProbSnow to our advantage? The information is still really helpful. There's still value in it. A couple of recommendations here. First and foremost, really recommend displaying probabilistic data in 3 tiered categories. Yellow, orange, red is a really good scheme because yellow, orange, red is just ubiquitous in our society. Look at stoplights, look at different threat levels for different impacts like a bioterrorism or pandemic level across the United States. it's hard to make decisions with 10 bins of probabilities. If I go back to this ProbSnow graphic here, if I'm in Ottawa versus Joliet, I don't know really what the relative difference is there. Maybe we're looking at a difference from like 30 to 50%. How can I make a decision based off of that? There's too many categories. If we were to simplify it into 3 different categories, there's one other category not shown in this map that's high, that's greater than 70%. That makes it much more easier to know, okay, I'm in the top level here. I'm in a 70 or 80% chance, therefore I know I have a relatively high chance. I also recommend that we don't use this blue color table. It's not colorblind friendly. I myself am colorblind. I actually don't see much of a difference from like Elgin to Joliet, if I'm being completely honest with you. It all just kind of looks the same to me. And sure, while there may still be challenge with the color blindness between, let's say, yellows and oranges and reds, if there's 3 distinct categories, it's a lot easier to discern the difference. Even if, maybe I'm not seeing truly the color orange, I know it's a different shade than the yellow. In addition, it's critically important to provide meaning to ProbSnow or ProbIce information correlating to impacts. So for example, what we do in our office here is anytime we show a ProbSnow graphic is we always say, let's say the worst conditions are expected in the orange shaded area, or slippery travel work will occur in all areas. If we were to send out a ProbSnow map, probability of greater than 2 inches of snow, let me go back to this example here. If you're in DeKalb, does this send the message that my commute's gonna be completely fine tomorrow? That's the wrong message. In reality, anybody that has shading here is gonna have problems. Now, how do we actually connect better the impacts? And the WSSI shows really good promise with this, especially the probabilistic WSSI that's being tested this year. I do have to offer just one critique. I'm not a fan of the minor, moderate, major impacts, since those are words of estimated intensity. What we're doing here at our office, we're actually assigning a ranking system. It goes from 1 to 5, 1 being really no impacts. And we're trying to categorize this based on what we know are impacts. And yes, there's still words of estimated impacts embedded in these ranking systems. I acknowledge that, but at least it's a little bit more clear of what you can expect. But the probability of reaching a specific category, whether it's 3 or 4, may be more closely tied to impacts. So maybe the probability or the prob WSSI impact level based on snow amount or snow rate correlates well with the probability of dangerous roads. Maybe prob WSI of snow load and ice amount correlates well to the power outage potential. And maybe in the future, we can create maps like this, the probability of dangerous road conditions based off of the probabilistic WSSI, that rather than focusing on a specific threshold, let's say 6 or 8 inches, it's focusing on an impact. And I reckon our partners can make much better information or much better decisions given this information. I don't think we're quite here yet. The prob WSSI and the WSSI still runs a little hot in my opinion. I know there's some really good changes that were made this year, particularly with snow amount, where the highest category, category 5, should be really rare based on climatology. But I think this is the future. This is where we're heading, and I'm really excited to be able to use this information in the future. Now, something we're doing at NW Chicago starting this year is we're actually introducing winter threat levels. And this is largely based on the WSSI, but we're making a few local tweaks based off our own discretion and our own knowledge of impacts in our area and the Chicago metropolitan area. But we have 5 different categories we're using, and this is going to be driving our messaging, and it's very much connected to our ops tempo, like our trigger chart, where we have different categories, level 1 through 5, based on our expected impacts. And we're also going to try to tie them into a typical product that's in effect. It's not one-to-one. We don't want to be handcuffed where we have a specific product, we must use a different color. But this is what we're going to be experimenting with this year. And most of our events are going to be somewhere in this level 2 to level 3, yellow and orange. We're looking at travel impacts to significant impacts. And again, words of estimated intensity are embedded in there, but we're still using some of those recommended strategies like a ranking system here. And WSSI can really help inform us to what we can use as our messaging strategy. A great example for today, we issued a winter weather advisory for Porter County, that's in northwestern Indiana, for the expectation of a lake effect snow band coming in. There's some potential that this snow band could be pretty horrendous with snow rates in excess of 2 inches per hour. And we may actually knock up our messaging threshold to a level 3 to orange, even though we still have a winter weather advisory in effect, just to really hit that point home that we're expecting this to be a pretty big deal. So this is something we're experimenting with this year. We have more information on the website listed below, and we may tweak it going forward here, but we think this is going to be the future of messaging going forward. The last few minutes here, I do want to just mention that it's not just snow amounts that misses critical information. Naked numbers with respect to QPF forecasts are or had the same problems. So a forecast like this is from a map that we sent out. I don't remember the exact date, but it's missing information such as the rainfall rate, the duration of rainfall, antecedent conditions of the time of year. Anytime I see a graphic put out in a DSS packet or a weather story, I always ask myself, is the rain actually going to cause any impacts? So we have this dashed line across the southeastern portion of this map with 1.0 to 1.5 inches. And I say, okay, is that actually going to cause any problems? Is this falling in 1 hour, 30 minutes, or is this falling over 12 hours? Are we in a drought? Did that area see 20 inches of rain last month? All of that is critical information to message and to use to provide that message. Are rivers going to rise? I mean, just looking at this map, I don't know. I can't make that determination. So if I can't make that determination, how can the public? And same thing goes for wind speed. We talked about wind speed a little bit here as well. It's missing critical information such as the duration of winds. Is this lasting 10 minutes or is it lasting 10 hours? The wind direction, is this right off the lake where Chicago's completely exposed, or is it out of the west? And the time of year, 50 to 60 mile-an-hour winds in December are completely different than 50 to 60 mile-an-hour winds in June when trees have a full foliage. That's all critical information as well. And when we put out a map that just shows a wind gust forecast, that really doesn't give an idea of tree damage or power outages. Again, I don't know what power poles are rated to. I think it's important that we work with our partners to figure out what are these thresholds and we can connect them to the impacts. So I'm going to wrap it up here. I do have a quick guide here, effective communication tip sheet. It was created for the NWA conference, but it's good for this audience here as well. There's a QR code on there. You can take a quick picture of this if you want. But this goes over all the strategies we talked about and other strategies that I didn't have the time to talk about today as well. Keep in mind, I'm a meteorologist. I'm not a social scientist, so I don't have all the answers. These are just recommendations that I've seen in my time looking at social science and in my own experience from getting questions from friends and family anytime we have any forecast for hazardous weather information. So with that, I'm going to wrap it up here. I don't know if we have time for questions, but if not, you can shoot me a quick email. And that's all I have. Thank you for everyone's time.